Catan Army. I hope that you all are doing amazing, staying hydrated and healthy. Here I am, your chemistry master teacher Shilpi Kaushik Vedantu, and coming with the second session of the very first chapter of class 9 CBSE chemistry, that is matter in our surroundings. And let me remind you that guys, Prodigy has already been started. So if you haven't taken the sessions yet, then please watch the last session. We have already started this chapter, which is really very important because you know that this chapter is also going to continue in the second phase as well. So what we are going to do, the characteristics of particles of matter. Before that, I lately came to know that you guys are very good at riddles, huh? I have one for you. I was not born, but I am here. I have no name, but I am given many. I was made by science and life. What am I? मतलब मुझे तो ना कुछ मतलब दिमाग में भी नहीं आ रहा है. आई एम नॉट इवन एबल टू गेस एनीथिंग. आई एम सो बैड एट रिडल्स. आई टोल्ड यू ऑलरेडी. सो यू गाइज गिव मी द आंसर इन द कमेंट बॉक्स एंड आई नो यू हैव ऑलरेडी गेस्ड इट. यस, एंड यू कैन ऑलवेज डिस्कस विद योर फ्रेंड्स. ठीक है, even when the sessions are premiered, then you don't have to think that ma'am is not looking at the answers. I am still here with you, right? So let's begin with today's topic, matter in our surroundings, session number 2. By the end of this video, we would be able to understand the properties of states of matter. Okay, so in the last class क्या किया था, एक बार जल्दी से let's do a quick recap so that if in case you missed the last class, you can still connect to this session. So in the last class, we started talking about the matter, that what exactly is matter. You are matter, like you do matter to Shilpi ma'am. Shilpi ma'am matters to you too, isn't it? Yeah. Okay, so matter is anything that is basically having some mass, that is occupying some space, and its presence we can feel with any of our 5 sense organs. And we have discussed that any object, you have your bottle, laptop, pen, tablet, this pen, whatever, the watch, they are all matter, right? Then we discuss what is not matter. Basically the human emotions, the feelings, they are not categorized as matters because we are not able to quantify them. They don't have any mass or space, etc. After that, we discussed the characteristics of particles of matter, in which I told you that matter has so many tiny particles in it, and the size of these particles is very small. Just as Shilpi ma'am is very small, just like that. Okay, then the next thing, these particles of matter have spaces between them, like you are adding sugar into water and the sugar is disappearing. So where is that sugar disappearing? It's getting into the spaces present between the water particles, and the volume also remains same when you add sugar into water. Okay, that's because of these spaces. The next thing, you understood that particles of matter are continuously moving. That is why you are getting the smell of a perfume that some another person has used, because the fragrance particles are continuously moving and reaching to you. Then the next thing we discussed was that these have certain attractions between them. So if you have to break any matter, let's say I have to break this pen, so I gotta apply some force, right? And that force will be repelled by the force of attraction between these particles. उसके बाद हमने किया था the different states of matter, where we discuss solids, liquids and gases. So today we would be discussing them in detail, as well as we would be discussing about the 4th and 5th state of matter. So I guess you all are ready. You have a clear picture in your mind that what we're gonna do in this session. Jaldi si send me your favorite emoji in the chat box, whatever it is. And you know ma'am just loves emojis. So send me any of your favorite one. Blue heart I would prefer, right? Okay, so let's start the very first thing. So states of matter में let's study about solids first of all. ठीक है, देखो solid कैसे आप imagine करोगे? If you have a look around you, then the maximum things are made up of solids. They are solids rather. You have a pen, मतलब देख के पता चलेगा मैम it's a solid. Like I am having a glass, I am having a cup. This is also, you can say ma'am it is also solid. Your laptop body, your tables, maybe you're sitting on a bed like that. How would I know, है ना? That is also solid. So how you gonna imagine solids? Imagine एक family है, ठीक है. सॉलिड्स आर फ्रॉम अ वेरी स्ट्रिक्ट फैमिली. जैसे होते हैं ना सम ऑफ माई फ्रेंड्स आर हैविंग वेरी स्ट्रिक्ट पेरेंट्स, लाइक दे डोंट allow my friends to go anywhere. You cannot go on a school trip, on a tour. You cannot, you have to be at home by 5 p.m. in the evening. You cannot go out on weekends. So that strict family where parents are not letting their kids go anywhere. बिल्कुल वही सिचुएशन है सॉलिड्स के साथ. सो इफ यू हैव अ लुक एट द पिक्चर, देन दीज स्मॉल स्मॉल स्फेरिकल बॉल्स दैट यू कैन सी, दे आर द पार्टिकल्स बेसिकली, एंड दीज पार्टिकल्स आर वेरी 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 टाइटली हेल्ड टू ईच अदर. सो आई कैन से दैट द इंटरमॉलिक्यूलर फोर्सेज ऑफ अट्रैक्शंस बिटवीन द सॉलिड पार्टिकल्स इज वेरी हाई. अगर ये पेन है ना, सो पेन के पार्टिकल्स में इफ आई गो ऑन द माइक्रोस्कोपिक लेवल, इफ यू जूम एंड जस्ट चेक व्हाट इज हैपनिंग इनसाइड द पेन पार्टिकल्स, then they would be present like that, just sticked with each other because of very high interparticle बोल सकते हो, or you can also say intermolecular forces of attraction. I'm writing by FO, okay, in short. Okay, so strong intermolecular force of attractions are there, and you can see that the space between the particles तो बिल्कुल negligible है. So this is one particle, this is another particle, the next, and these are the only spaces present between them. So I can say that they have negligible interparticle spaces. So now you can relate it. So tell me how many of you are from the solid family, like you're not allowed to do anything much. So let me know in the chat box. Anyway, so you can see they are also vibrating, right? ऐसे ऐसे आप देख सकते हो, they are continuously vibrating. So what is the reason for that? Because solid में particles have very low kinetic energy. Kinetic energy कैसे हो सकता है? If they are not even allowed to go anywhere, they are so tightly held to each other that they are not free to move. So when the motion is ceased, I can say that kinetic energy भी तो कम ही होगा, isn't it? So the same thing is happening. The kinetic energy is very 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 less. So मतलब you can say it's almost negligible. So all that solids में particles have the motion is the vibration. So I can say that they are merely vibrating about their mean positions. Okay, that is the scenario. Now let's go and check how exactly is it impacting the properties of solids. Then solids have a fixed shape and fixed volume. True that. देखो, I have a pen, ठीक है. अब ये pen is always gonna have this fixed shape. If I check this pen, let's say after 10 years, आफ्टर 10 ईयर्स से शिल्पी मैम तो बूढ़ी हो जाएंगी, ठीक है. 10 साल के बाद भी ना ये पेन जो है इट विल रिमेन इन द सेम शेप, बिकॉज पार्टिकल्स हैव सो मच ऑफ इंटरैक्शन, दे हैव सो मच ऑफ फोर्सेस ऑफ अट्रैक्शंस बिटवीन ईच अदर, एंड इट विल स्टिल ऑक्यूपाई द फिक्स्ड सेम वॉल्यूम. सो लेट्स से आई एम कीपिंग दिस पेन ओवर माई हैंड, इट इज ऑक्यूपाइंग सम volume, some space. So the same space it's gonna occupy on my another hand, या फिर if I keep it on the table, still उसने सेम ही स्पेस ऑक्यूपाई किया है. सो वॉल्यूम इज, यू कैन जस्ट अंडरस्टैंड इट इन टर्म्स ऑफ द स्पेस. हाउ मच स्पेस अ सब्सटेंस इज ऑक्यूपाइंग, दैट इज इट्स वॉल्यूम. ओके, सो सॉलिड्स हैव दैट फिक्स्ड शेप, they have a fixed volume. The next point is that they are generally incompressible in nature. How do you define compressibility? Just tell me in the chat box. Meanwhile, I remove it. Okay. Yeah, so how do you define compressibility? Compressibility को आप define कर सकते हो like let's say I have a system. ठीक है, imagine this is a system and I start applying pressure on it. You are applying external pressure on the system. So how much volume is reduced? That is its compressibility. So it is defined as the reduction in volume on applying pressure on a system, right? So I'm just penning it down here. Reduction in volume on applying pressure is something that I call as compressibility. Try to understand the points. What is the scenario in case of your solids? Solids में particles are already at the maximum closeness. They do not have spaces between them. Like there are some spaces, but you know they are negligible. So if you start applying pressure on the solid, then there is not going to be any reduction in the volume. जैसे देखो, imagine करिए bottle है, ठीक है. आई स्टार्ट अप्लाइंग प्रेशर, इमेजिन क्या करना, बॉटल ही है ये. ओके, सो आई स्टार्ट अप्लाइंग प्रेशर ऑन इट. believe me, I'm applying a lot of pressure, right? But there is still no reduction in the volume. Again, you know the reason, particles are so close that they'll say, अरे भाई क्या कर रहे हो, अब कितना close होंगे हम, we are already at the maximum closeness. So that is why they are generally लिखा है, they are generally incompressible in nature. Why generally? Because there is an exception. If you talk about sponge, you would have seen sponge. Sponge is a solid, but still sponge is compressible in nature. If you know the answer, then give me the answer in the comment box or in the chat box. So what is the reason? I'm going to tell you. Sponge basically has holes in it. ठीक है, बहुत टाइनी पोर्स होते हैं, छोटे 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 टाइनी पोर्स आर देयर एंड एयर एंटर थ्रू दोज टाइनी पोर्स. सो नाउ व्हाट इज द सिचुएशन? एयर इज एंट्रैप्ड इन दैट स्पॉन्ज. सो व्हेन यू कंप्रेस इट, देन दैट एयर एक्सपेल्स आउट. सो यू फील, अरे ये तो कंप्रेसिबल है. सो दैट इज एन एक्सेप्शन. यू कैन जस्ट रिमेंबर दैट, राइट? Third one, the particles in solids are tightly packed. That is very true. Now apart from that, I am some examples are given that we don't need to see, of course. चलो और property discuss करते हैं. If I talk about rigidity, rigidity बहुत हाई होता है सॉलिड्स के केस में. नाउ व्हाट इज रिजिडिटी? यू वुड हैव यूज्ड दिस टर्म इन वेरी जनरल ऑल्सो फॉर पीपल हु आर वेरी स्ट्रॉन्ग. यार ही इज सो रिजिड, शी इज सो रिजिड, उसे फर्क ही नहीं पड़ता है, isn't it? No matter what the situation is. So rigidity is the tendency of a solid to maintain its shape. I'm penning it down here so you can note it. Tendency to maintain the shape. And one more thing, you can download the PDF of this class notes from the description box. ठीक है, it would be uploaded you can say after 3 to 5 hours maximum. So just check the video again and download the notes. Okay. Yeah, so tendency to maintain the shape is something that I call as rigidity. So फिर से we will take the example of the bottle. So आप देख सकते हो, it is so rigid. So I am applying a lot of force, but still it is just not getting affected. So solids are generally very rigid. ठीक है. Apart from this, if I talk about the density, this is a symbol for density. मैं लिख देती हूँ if you get confused. That is defined as mass per unit volume. राइट. सो डेंसिटी भी बहुत हाई होती है सॉलिड्स की. व्हाट इज द रीजन फॉर दैट? बिकॉज दे हैव वेरी ह्यूज मास वैल्यूज. नाउ मास कैसे डिफाइन कर सकते हो आप? मास इज सिंपली द नंबर ऑफ पार्टिकल्स प्रेजेंट इन अ सिस्टम. ठीक है, हाउ मेनी पार्टिकल्स आर प्रेजेंट इन दैट पर्टिकुलर सब्सटेंस. इन सॉलिड्स में बिकॉज पार्टिकल्स आर एट द मैक्सिमम क्लोजनेस, सो देर आर अ लॉट ऑफ पार्टिकल्स विच आर प्रेजेंट एंड डेंसिटी इज डायरेक्टली प्रोपोर्शनल टू मास. So keeping the volume constant, so you can say that usually gases के केस में तो it's the least, but solids have very 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 high density. Okay, so here comes a homework question for you. Tana. चलो question ले लो. I will write it in blue color. Solids have highest density, but still you have to tell me ice floats on water. It has something to do with the structure of ice. Check करना एक बार. Ice floats on water in the comment box. ज़्यादा questions तो नहीं दिया ना homework में. I guess you can manage that. Okay. ठीक है. Now coming to the next point. अरे we have a meme. When students get to know there is no mentee in the session. My goodness. I don't understand. You know what happens? जैसे ही students आते हैं session में, the first question, ma'am, is this a live session or not? मतलब attending a premiere session is against my ego. This is how it works. I don't know like क्या difference होता है. देखो, even if the session is a premiere session, so you think that your doubts won't be resolved, you can always leave your doubts in the comment section, because we will have a doubts plus mentee session at the end. After covering all the theory only ना, we will have mentee. या फिर first class से I start having the mentee. Okay, tell me what is the age of Shilpi ma'am. Okay, so you have to be patient enough. So theory भी करना बहुत ज़रूरी है. Only then we would be able to do the questions, isn't it? या फिर there is no mentee. I am not attending this session. Only 10 live watching. So please guys, मतलब थोड़ा पेशेंस रखा करो यार. क्या करना है ज़िंदगी में? मतलब इतना जल्दबाजी करके क्या करना है? Anyway, the next is the liquid state. Liquid से पहले we will be discussing the अच्छा सा वर्ड gases. ठीक है. Gaseous state में ये क्या है? Steam दिखाया हुआ है आपको स्क्रीन पर, and steam is simply the water vapors. पानी को बॉईल कर दो, द वेपर्स आर द स्टीम ओनली. सो गैशियस में क्या होगा, सॉलिड में यू हैव सीन द पार्टिकल्स वर फ्रॉम अ वेरी रिजिड फैमिली, मतलब कुछ नहीं करना है, कहीं नहीं जाना. बट गैशियस स्टेट में देयर इज स्टिल सम लिबरलाइजेशन दैट दे गेटिंग, राइट. सो यहाँ पर क्या होता है, पेरेंट्स आर नॉट वेरी स्ट्रिक्ट. ये तो बिल्कुल ही दे आर लाइक दे हैव लेफ्ट देयर चिल्ड्रन सो फ्री. यू जस्ट गो एंड हैव, you just go and stay at your friend's place, ठीक है. You can bunk your classes, you can do any XYZ thing, so they are really not concerned about that. So यहाँ पर क्या होगा, gaseous state में particles are at the maximum distance from each other, मतलब मैक्सिमम समझ जाओ जितना दूर हो सकता है, मैक्सिमम डिस्टेंस, ठीक है. एंड द इंटर पार्टिकल फोर्सेज ऑफ अट्रैक्शन आर नेग्लिजिबल. सो आई एम पेनिंग इट डाउन हेयर. Intermolecular forces of attraction for the gases are the least and the spaces between the particles is maximum. How many of you are from the gaseous state वाला family? मैं तो नहीं हूँ. My parents are not इतने free that अरे you go and have some night outs or you stay with your friends. No, not like that. Anyway, ठीक है. How the properties are impacted, let's have a look at them. Gases have no fixed shape and no fixed volume. ये तो आपने देखा होगा. If you have seen, if you have observed keenly on birthday parties, so you would have seen different shape के balloons होते हैं, है ना. कोई मिक्की माउस का balloon है, some heart, Valentine's Day पे you're getting the heart वाले balloons. So that is clearly telling you that air is gonna occupy the shape of the container in which you are keeping it. Doesn't matter आप किस में रखते हो, it's still gonna occupy the same shape. So they don't have any fixed shape. The next thing, they don't have a fixed volume either. I told you from a very liberal family. अरे कुछ ज़रूरत नहीं है, you don't need to have fixed shape or volume. So volume में आपने देखा होगा the best example LPG gas cylinders. So whenever there is a gas leakage, then the smell is gonna scatter in the entire house. Why? Because gaseous particles are at such a huge distance that they, you know, if you give them this much space, they will occupy the entire volume. अगर आप इतना space दोगे, they will occupy that. Even if you give them 1000 ml container, they all are gonna just occupy that. ठीक है. So this is also not fixed. Second thing, gases are highly compressible in nature. Highly compressible in nature, and the best example for this is the LPG gas cylinders. और आपने अभी तो कोविड के टाइम पे ऑक्सीजन सिलेंडर्स आर इन इतना ज़्यादा डिमांड, सो यू वुड हैव सीन दैट. How they are compressed here, how we have used compressibility, this I will tell you in like 3rd or 4th class, ठीक है, when we will study the interconversion of states of matter. So what is the reason that gases are highly compressible in nature? Again, the space between the particles, मतलब इतना सारा space है particles के बीच में that when you apply pressure on them, then the particles of gas start coming closer to each other. So develop some attractions between them, and a stage is reached when finally you get a liquid. Sometimes they can get converted to solid directly as well. Okay, the particles in gas are loosely packed. I have already told you, we have seen some examples as well. चलो एक बार liquid की भी बात कर लेते हैं जल्दी सी. That is left. Yeah. The next is the liquid state. Now I am from liquid वाला family. Like my parents are not so strict, या फिर इतना भी नहीं है कि you just go anywhere anytime. So like intermediate. कभी कभी जा सकते हो ट्रिप्स पे, कभी नहीं भी जा सकते हो. सो यू हैव टू जस्ट obey whatever they are saying. So liquid state में if I talk about the particles, जैसे you can see water can easily flow. You have seen a river is flowing, or water bottle में you can shake the water easily. So what exactly is happening in the liquid state? Particles do have some spaces between them, but these spaces are more than solids, less than gases. So ये ना मतलब you can say they are just always swinging between solids and the gases, बीच का रास्ता. Okay, if I talk about the forces of attractions, then forces of attractions are less than those in the solids but more than that in the liquids, right? So as a result of which, how the properties are impacted? The first thing, they do not have a fixed shape. So ये तो आपने देखा ही है स्कूल में, every kid is having a different shape water bottle, है ना. जैसे this cup is also having hot water, इस bottle में भी hot water है, so it is having different shapes. occupy the shape of container, they have a fixed volume. So let's say I am having 25 ml water in this glass. If I transfer it to any other container, the volume will still remain same, isn't it? So I am avoiding the human error. आपने गलती से गिरा दिया, that is your problem, right? So they don't have a fixed shape, they have a fixed volume. Liquids are generally incompressible in nature. So आपने देखा भी होगा when you are taking a bath, if you try to just move your hand in the bucket filled with water, so water is not compressible. Again, इतना space नहीं होता है that they can be compressed like that in the gases. So compressibility, I can say more than that of the liquids but less than that of the gases. Okay. Particles are moderately packed. This we have already discussed and examples भी हमें पता है, ठीक है? So that is between these three states of matter. Let's revise. Okay. So we have discussed a lot of properties. Mass, shape, volume, compressibility, fluidity I have told you. अच्छा no. Solids में I told you they are highly rigid. ठीक है, बहुत स्ट्रॉन्ग अट्रैक्शंस है एंड लिक्विड्स एंड गैसेस आर नॉट रिजिड एट ऑल, सो देयर टेंडेंसी टू विदस्टैंड द फोर्स और द प्रेशर इज नॉट दैट ग्रेट. जैसे गैस बलून जो है यू कैन जस्ट बर्स्ट इज इजीली इवन विद स्लाइट अमाउंट ऑफ फोर्स. That's what you do on birthday parties, isn't it? And fluidity is not possible for the solids. You have seen the maximum solids can do is to vibrate about their positions. They are not allowed to move freely. But if I talk about the liquids and gases, वहाँ पर particles can easily move. They don't have that much forces of attractions. इसका best example आपने देखा है, river में पानी is also flowing. And again you have incense stick का example I took in the last class. परफ्यूम बॉटल की बात कर सकते हो. सो गैशियस पार्टिकल्स आर फ्लोइंग, दे आर डिफ्यूजिंग थ्रू एयर. ओके, ठीक है. द डिफ्यूजन इज अगैन सॉलिड्स. डिफ्यूजन इज बेसिकली इंटरमिक्सिंग ऑफ पार्टिकल्स ऑफ मैटर. सो डिफ्यूजन सॉलिड्स में हो ही कैसे सकता है व्हेन दे आर जस्ट बाउंड टू ईच अदर सो टाइटली. ओके, एंड इट वुड बी मैक्सिमम फॉर द गैसेस. दैट्स क्लियर. एंड स्पेस एंड दिस फोर्सेस वी हैव डिस्कस्ड. ठीक है. चलो, the very next thing, do you know other than these three states of matter, two other states of matter also there, and you people gave me the right answer in the comment box of last video. I checked those answers. Plasma. Plasma is the fourth state of matter. Can you guys tell me in the chat box कहाँ पर आपने plasma को feel किया है और where we are using the application? Just let me know in the chat box. Stay hydrated, keep drinking lot of water as well. ठीक है. देखो, plasma is also obtained from the gas only. Solid, liquid, gas आपको मिल गया. If you take a gas at very high temperature, मतलब इतना high temperature आप imagine कर लो that gases में से electrons start coming out. You have taken a gas at an extremely high temperature. So at such a high temperature, what happens? Gases start existing as the ions. जैसे you have seen, देखो, this is an atom, nucleus, and this is the electron. Electron is very loosely held to the atom basically, बहुत like lightly held होता है. So if the atoms are colliding with each other at such a super high temperature, then electrons are ejected out very easily. Then what we get the ionized gases, you can say, and these ionized gases further keep on colliding and they would be producing a glow in them that leads to a light. जैसे इसका बेस्ट एग्जाम्पल होता है सन and the stars. So sun and star पे आपने देखा है plasma is present. If I talk about the sun, so वहाँ पर क्या होता है? We have the helium there. Helium gas is there at sun and that too at very high temperature. ठीक है. So what happens? Again the atoms are going to collide and we would be getting the ionized gases then. And these ionized gases are ready to glow and you see that sun may glow and the stars are also glowing because of the same reason, right? Apart from this, where you have seen the application, इसके अलावा आपने देखा है साइन बल्ब्स में. जैसे if you have ever keenly observed, जो ट्रैफिक पुलिस होता है ना, ट्रैफिक पुलिस के पास एक रॉड होता है with which they give the instructions, go left, go right, this and that, and that road keeps on glowing. साइन बल्ब्स होते हैं, दे कीप ऑन ग्लोइंग. सो व्हाट इज द रीजन फॉर दैट? बिकॉज दे आर ऑल्सो फिल्ड विद द गैस. जनरली जो गैस यूज होता है दैट इज ईदर हीलियम और आर्गन, द इनर्ट गैसेज बेसिकली. सो व्हाट हैपन्स, दे हैव अ स्विच ऑन दैट रोड. जैसे स्विच है, दे विल जस्ट टर्न ऑन दैट स्विच. उससे क्या होगा? इलेक्ट्रिसिटी वुड बी पास्ड. Again these atoms of the gases start colliding and then they get converted to ions which further produce the glow and you see that ninja lights में भी आपने देखा होगा. So this is how it happens. ठीक है. The next one is the fifth state of matter, Bose-Einstein condensate. ऐसा नाम क्यों है अजीब सा, बोज-आइंस्टीन कॉन्डेंसेट? बिकॉज बोज इज द नेम ऑफ एन इंडियन साइंटिस्ट एंड आइंस्टीन को तो आप जानते ही हो. सो बोज ने बोला था यार मुझे ना लगता है देयर इज वन मोर स्टेट ऑफ मैटर, I am getting some intuitions. Then Einstein was like, okay, I will just convert your intuition into reality. So they together started talking about it. The major research was done by Sir Einstein only, right? So how this is obtained? This is also obtained from a gas. आपको एक गैस लेना होता है. कैसा गैस? यू हैव टू टेक अ गैस ऑफ एक्सट्रीमली लो डेंसिटी, मतलब बहुत कम डेंसिटी का आपने गैस ले लिया. ठीक है. देन व्हाट यू हैव टू डू, यू हैव टू टेक इट एट अ वेरी लो टेम्परेचर. उल्टा कर रहे हो आप. लाइक इन द केस ऑफ प्लाज्मा वी टुक अ गैस टू अ वेरी हाई टेम्परेचर. इन BEC वी आर टेकिंग अ गैस ऑफ एक्सट्रीमली लो डेंसिटी sorry, and we are bringing it at a super low temperature. So when you are taking it at very low temperature, what is going to happen? Gaseous particles will lose their kinetic energy. Kinetic energy lose करेंगे, they will start coming closer to each other. So a state will come where these particles get converted to a super cool फ्लूइड. ठीक है. आपको सुपर कूल लिक्विड और यू कैन से फ्लूइड ऑब्टेन होता है. सो सुपर सैचुरेटेड यू कैन से, दैट वुड बी अ बेटर टर्म. सुपर सैचुरेटेड स्टेट you are getting. So at this super saturated state you can say particles do not have any more spaces between them, that something else can be accommodated, right? And the kinetic energy itna loses that a gas condenses. Gas is gonna condense at such a super low temperature. That is why the name is Bose-Einstein condensate. The gases condensing, particles are coming closer to each other. Where you have seen the applications, इसके applications quantum computers में भी होते हैं, super computers में it is used. And apart from that major uses superconductors. Superconductors में क्या होता है? जैसे देखो, these are the substances. I've taken a superconductor, I am passing some current through it. So जितना आप करंट पास करोगे you are about to get the 100% of that current. Although 100% कुछ भी नहीं होता है, that is an ideal situation. It's like around 99% तक आपको मिल सकता है. So I can say there is no resistance basically. No resistance is felt by the substance. Whatever is the amount of current that we are passing, the same amount is going to come out of it. ठीक है. So you have to remember that. And the same in the superfluids, they are always moving. They keep on flowing and flowing and flowing. So let's discuss a few questions. The force that binds the particles of matter together is known as. Give me the answers in the chat box, and if your friends are giving the wrong answers, then help them. ठीक है. Just show some empathy, and we have to always be soft-hearted, kind people, isn't it? So the answer is intermolecular forces. We have discussed it already. The state of matter which consists of super energetic particles in the form of ionized gases is BEC, solid. That is plasma state. Clearly you know that. Sun, stars, we have taken the example. This is your homework question. Which of the following describes the liquid phase? कमेंट बॉक्स में आंसर देने के लिए यू डोंट हैव टू राइट द कंप्लीट वन, जस्ट ऑप्शन लिख देना A, B, C और D, वॉट एवर इट इज. देख लो ध्यान से, टेक अ स्क्रीनशॉट एंड राइट द आंसर इन द कमेंट सेक्शन. ठीक है. सो व्हाट वी विल बी डिस्कसिंग इन द नेक्स्ट सेशन, हाउ डज मैटर चेंज इट्स स्टेट. ओ माय गॉड, दिस इज सुपर इम्पॉर्टेंट. ये समझ लिया ना, बस मज़ा आ जाएगा. You'll be like, अरे मैम यार क्या. Okay, so that's all for today's session. Do not forget to share this video and subscribe to the channel for more amazing videos of the Prodigy series. Do not miss any session. We will have Menti very soon. Okay, so thank you so much for your patience. If you have any other doubt, you can reach out to me on Instagram. I am Katine is my ID. Okay, ma'am, we'll see you next time. Take care and bye-bye.